Welcome to Easy Gates Electrical Gate 22 Solutions. The next problem is 36, an interesting one from analog electronics using an operational amplifier which is non-ideal. Okay, in many aspects, but what aspects we need, in what aspects it is non-ideal, we should know. Then we can play with the problem. Okay, the output impedance of a non-ideal op amp is denoted by Z out. Usually, habit is we represent an op amp with the input resistance. So here impedance is mentioned. So let me go for the impedance. Let us have the input impedance of the op amp as Z10. That is Z10. Then we have a gain dependent voltage source representation. So this is usually we take it as A naught. Since it is mentioned as a non-ideal op amp, let me take it as A of S. Gain, okay, as a function of the frequency, where A of S will be equal to A naught will be the open loop gain of the op amp divided by 1 plus, let me take S by omega C. That's a ideal way how the frequency response of op amp will look like. Okay, so this is A naught. Okay, this is the cutoff frequency omega C, an asymptotic Bode magnitude plot. Okay, for this. Okay, that's your transfer function. Okay, for the practical op amp, assuming this. Okay, because some play is there with respect to the transfer function. Let me take A of S. A of S into what? The voltage VD. Okay, so this is plus and this is non-inverting. This is inverting. So non-inverting connected to the voltage, input voltage V in of S, let me say. And then here we have the output impedance Z naught. That is what mentioned as Z out. I'll take it as Z naught. Okay, this is Z naught output impedance. Okay. So then around this we have a unity feedback. That's a buffer circuit, non-inverting amplifier. We have a unity feedback. This is what given is. Okay. So problem is, what is a impedance for this closed loop structure? Okay, so that means the focus is on Z naught CL. Okay, focuses on Z naught CL means that you are exciting here by a voltage V out. Okay, and looking for a current I. Okay, V out by I will give Z naught CL. There is a condition for this. You have to switch off your V in. So V in must be made 0. So make V in 0, then let us go for Z naught under the closed loop condition. That is what he is talking about. So the statement is the variation in magnitude of Z out, that is Z naught closed loop only is talking about. So we need to find out Z naught closed loop of S. Okay, so then we'll comment on this. So let us find this Z naught closed loop, the closed loop impedance of this op amp buffer circuit. Okay, voltage follower circuit can be best represented by what Bode plot. Okay, so log of your Z naught CL is talking about the magnitude of your output impedance of this closed loop system with respect to the frequency. Okay, yes, we'll see. So what does Z naught CL will see? So V in is made 0. Since V in is made 0, so this point potential is 0. Okay, so this is what exactly the voltage VD is earlier. This is plus and this is minus. Okay, since I'm exiting here by V out, this is also going to be V out. And this is also going to be V out. If that is the case, what does my VD means? VD is non-inverting minus inverting. So non-inverting is connected to ground. So VD is equal to, that is V minus equal to V out. Therefore, VD equal to minus V out. Now let us comment on the current I. So we'll go for the Z naught CL. So we're looking for the current. So this point is V out, we know. And now this point, you know, this is nothing but A of S into what? VD. So then the current is not going to exist here. Okay, assuming the Z10 is very large enough, closer to infinity, let me take this current 0. Therefore, the I will exist only here. So then I will say I is equal to V out minus what? A of S into VD divided by what? The Z naught. So we'll go for what is Z naught CL? That is nothing but V out applied at the output terminal I provided V in is made 0. That's a fundamental for the closed loop output impedance. Stick to that, we'll get the answer easily. Okay. So Z naught CL shortly is V out by I under the given condition. So what is I? I is equal to V out minus A of S into VD. What is VD now? We know VD is equal to minus V out, substitute that, divided by Z naught. As a result, you will get V out, that's a supply injected at the output terminal, V out. Okay. So V out minus A of S into minus V out. So it's going to become plus A of S into V out. When you replace VD by minus V out, the whole divided by what? Z naught UK. Therefore, from this I is equal to predicate V out into 1 plus A of S, the whole divided by Z naught UK. Okay, the focus is on getting V out by I. That's our closed loop output impedance. So V out by I is equal to what you get is Z naught by 1 plus A of S. Okay, so you know that straight away. If it is a normal setup, you know that Z naught closed loop is equal to Z naught by 1 plus A naught into beta. So if no frequency response of op-amp is considered, then in this case beta is equal to 1. It is 1 plus A naught. Since instead of A naught, what we have is A. So that is also the way to connect directly from this to this. Okay, so but anyway, that is the desired V out by I. Okay, that's Z naught CL. Okay, so we'll focus on Z naught CL closed loop of S. What is that? That is equal to Z naught divided by 1 plus A of S. What is A of S? Already assumed. A of S in terms of open loop gain A naught and S by, there is a cutoff frequency omega C. So replace this. So then you will get Z naught by 1 plus A naught by 1 plus S by omega C. It's a low pass. So considering this, then you'll get Z naught divided by 1 plus S by omega C plus A naught you will get, and the numerator is going to become 1 plus S by omega C. So then the closed loop impedance, let me call this as Z of S shortly, Z of S closed loop output impedance is equal to what you get then. So it is Z naught, then take the real common. What is that? 1 plus A naught out. Then what is the remaining? The numerator will be 1 plus S by omega C, the whole divided by 1 plus S by 1 plus A naught into omega C. Okay, so this is a constant. Okay, and this is your, we have a pole zero structure. So this is a zero corner frequency, and this is a pole corner frequency. Who is higher? Zero corner frequency or pole corner frequency? Pole corner frequency is higher. So this is having a magnitude. Okay, so that means the Bode plot. When you have a pole and zero, so it's coming first, zero effect is coming first. Initially, this magnitude is going to play the role. This magnitude is constant, so the Bode plot will look like this. It's a constant. And who is coming into play? Zero is coming into play. The moment zero come into play, then the plot will increase by a slope of what? Plus 20 dB per decade. And then the pole is coming into play. The pole corner frequency is coming into play. Therefore, it is going to stay tiny. So that is how the plot of Z of S will look like. That's a Bode plot of Z of S. Okay, look for the structure. That is exactly your answer. Okay, so this is the best way to answer such a simple problem connected to the basic of closed loop system. Okay, so closed loop amplifier system. Only hint is you need to help yourself by considering A of S, that is a low pass. So that is in the form of, even you studied this in the control system, in the form of K by 1 plus S by omega C. Instead of K, you are replacing K by the open loop gain of your op-amp. That's all. Then it's very easy problem. So the best answer for this problem is option C. That's a way to proceed and get the answer instantly. Okay, so how you can help? This is only for a better understanding of the problem. The structure is needed. Otherwise, you can ideally start from this point. This ideal starting point is at not CL is decreasing. That is the output impedance due to the feedback is decreasing because output is voltage should decrease by 1 plus A naught beta. Beta given 1, you can take A naught 1 plus A naught, and instead of A naught, you go for the whole okay, structure of your op-amp transfer function. That is A of S, that is A naught by 1 plus S by omega C. With that you can connect, then you will have this field. Okay, that's a very interesting problem, one of the interesting problem from GATE 22 electrical paper. And hope you enjoyed this content, and do subscribe the channel and look for further updates. Thank you.